Hey y'all, this is Hilary Davis. I'm a master's student at the University of Idaho. I'm finishing up December 2014 and I'm going to give you a little snippet of what I've done. So some of you may know, but for those of you who don't, that I've worked on the longitudinal survey of wheat growers in our study area. And I've been doing that since I started here. Of course, all of the wonderful organizations that are part of REACCH and our grant number, all those wonderful things. So I'm first going to talk to you a little bit about the agroecological classes. Some of you may know these really well and some of you may not. So I'll go through them sort of quickly. The green on this map is the irrigated. So this is those that irrigate their crops. And as we move east, in rainfall slowly increases. So we have the grain fallow and the brown. The transitional is what I'm going to refer to it as, but it's the class between the annual crop and the grain fallow. So this transitional zone where you start seeing fallow in the rotation. And then the blue is our annual cropping region. So the data collection is from the longitudinal survey, and the longitudinal survey will be collected, or has been collected, from 2011 to 2014. The 2014 crop year data hasn't been collected yet, but it will be. So we collect planting and harvest data along with questions from REACCH scientists, which I won't talk about in this presentation at all. All of these interviews were personal and on farm because they took a lot of time and we collected a lot of information from them. So we also collected a schedule of operations, so we went through all of their operations for their wheat crop and then their machinery cost. These last two things, the schedule of operations and the machinery cost, are what went into this analysis. So those two things went into creating this enterprise budget. So for every grower in the survey, for every year, I created an enterprise budget, which has all of their variable cost, seed, fertilizer, machinery, and then it has their fixed cost, or ownership cost, depreciation, interest, all those fine things. So at the bottom of this, we have our total cost per acre. So this is everything they spent to make this acre of wheat. And then we have total cost per unit. So I circled all of these. And the total cost per unit is total cost per bushel in this case, because that's our unit of output. And the total cost per unit or per bushel takes out the yield differences between classes, which I'll reflect on a little bit more later. And then we have net returns over total cost, or returns to risk. Or another way most of you think of it is profit. So that's what they're making per acre. So what I wanted to do is look at those three economic variables and see if they are good economic variables for our classes. So the agroecological classes are separated by biological and agronomic differences. But I wanted to see if the classes worked also for economic variables, if we could see a difference between the economics of these farms between classes. So what I did is I did a pairwise comparison or multiple comparison. A very common one is Fisher's LSD. I didn't use Fisher's LSD. I used the Tukey-Kramer test. It's slightly more conservative and it allows for unequal group sizes. So I didn't have the same number of respondents in each class. And like I mentioned before, I did three economic variables: the total cost per acre, which can also be called total cost of production, our cost per bushel, and our returns to risk, or in other words, profit. So just to give you a little bit about the agronomic differences and biological differences between these classes, I've asked growers about their precipitation, their rotation, and yield every year. And so this is a summary of the data from the longitudinal survey. So they have annual precipitation, which you can see the annual in the most eastern part of our study area has the highest average precipitation, and then it falls off as we move west. For rotation, in the annual class, we have a pretty typical 3-year rotation of some sort of winter wheat, a spring grain, and then typically a legume. In the transition class, so the class between annual and grain fallow, where fallow starts showing up in the rotation, a typical 3-year rotation would be winter wheat, a spring grain, and then a year of fallow. And in grain fallow, it's mostly always winter wheat, summer fallow, with a few exceptions. And then the irrigated rotation varies greatly, and it's hard to categorize into anything really. In terms of yield, you can see that irrigated has the highest yield, mainly because they have an almost unlimited amount of water. And then behind them is the annual, has the highest, and then it drops off between transition and the grain fallow class. This is the yield data separated for each year between the different classes with standard deviation. And the first thing I did is I tested using the same Tukey-Kramer test as I use for the rest of the economic variables yield, because I first wanted to make sure that yield, which is very different between each one of these, was statistically significant. I wanted to know if the classes did a good job at explaining yield, and they did. At the 5% confident level, every class was significantly different from each other. So then I tested economic variables. The first one is total cost per acre. Just to remind you, this is everything that they spent per acre to get that acre of winter wheat. I guess I should mention these are all winter wheat numbers. So in this graph, I want you to note that each class stays relatively flat. There isn't a whole lot of difference between the annual, between the different years, right? And then similar with the other classes as well. So there's not a whole lot of difference in total cost per acre. This is the same data, it's just separated by year rather than class. And what I did is I compared the annual versus the transition and so on and so forth. So what I want you to notice is that the difference between each class and each year. So in 2011, there's not a whole lot of difference between the annual and the transition class, and whereas there's a huge difference in the irrigated class. And one thing to note in all of this analysis is I left irrigated out. I focused on the dryland classes because the irrigated caused a lot of problems in the statistical data and analysis. So I took it out and focused on comparing the dryland classes of wheat. So the test results show that at the 5% level, the transition class and the grain fallow class are significantly different for total costs. So their total costs are significantly different from each other. And similar with the annual and the grain fallow class, they're statistically different from each other. So the next one I looked at was cost per bushel. So this table's sort of overwhelming, but what I did was I tested each year separate from each other, and then I tested overall. So here's the data in slightly more visible figure. So you can see in some years the dryland classes aren't that different from each other for cost per bushel. In 2002, the annual and the transition are almost identical. And we'll see this showing up in the results, that they're not significantly different when they're so close. So our results for cost per bushel, as I mentioned, I did each year separate and then all of the years together. In 2011, there weren't any results because none of the dryland classes were different from each other. In 2012, only the annual and the grain fallow were different from each other for how much they're spending per bushel of grain to produce. In 2013, the transition and the grain fallow class become different from each other. But overall, when we lump the data together, only the annual and the grain fallow are significantly different. And as an economist, what I want to see is that these classes for cost per bushel aren't different. And that's because all of the growers in this region sell to the same market. It's not like the dryland people get a higher dollar per bushel than the annual class. So this is a good indicator of the different profit that each class will see. It's a lot easier for the annual class to make money because they have a much larger margin from their total cost per bushel versus what they can make per bushel. The last economic variable I tested was returns to risk. So here's a table of the returns to risk, and what you can see is that it's all over the place. There isn't really a good pattern going on. Generally, the irrigated has the smallest returns to risk, but in 2012 it was the highest. And they have really, really big standard errors. So within each class, there's a ton of variability about what growers are making per acre. And this is simply to do with what people spend money on. So some people have very expensive equipment which increases their machinery costs and decreases their returns. So I lumped these together, all of the years together, and only the annual and the grain fallow were statistically different from each other. So we can say that the annual class is more profitable than the grain fallow class in terms of average overall class statistics. So in conclusion, the agronomic variables, or the one I tested, yield, performed exactly how we thought it would. The economic variables, there's not a very good black and white. So for total cost per acre, the annual and the transition class were not different from each other. For cost per bushel, usually the annual and the grain fallow were different from each other, except in 2011. And then returns to risk, only annual and the grain fallow were statistically different from each other. So my takeaway from this is the annual and the transition class are more similar to each other than the transition and the grain fallow class, and that the annual class is more profitable overall in terms of winter wheat production, comparing all of the dryland classes. So that's all I have for you today, and I look forward to your questions.